The experiment is determination of true density. For find out in the true density, equipment and materials, what are the required equipments and materials? Here, in the equipment, dry oven is required. There we can see dry oven. And powders are required. Minus 72 BS mesh powders. This is the iron powder. Coke powder. Fire pit powder. And limestone powder. Now we are going to calculate the true density of two material out of these four. This is fire brick powder and limestone powder. The procedure is we'll take this minus 72 BH mesh powder material which has dried at 110 degrees centigrade for 2 hours. These powders are already dried at 110 degrees centigrade for 2 hours. So these are materials ready for the testing. This is the specific gravity bottle. This is also required. We have to keep the material in this specific gravity bottle. For weighing purpose, we use this balance. With the help of the burette, actually in the experiment, we have to fill the water after putting the material. For that, we can use the pipette also, or with the help of the pipette also we can do accurately. So again coming to the procedure, this powder material after drying at 1 degree centigrade for 2 hours, that material is ready for testing. So we'll wash the density bottle with the stopper. After that it should be dry. Then we'll take the weight. That will be the A. In this 5 to 15 grams of material, we'll take that 5 powder and limestone powder. We'll take into this. This bottle is small. Thus, in this experiment, we'll take 2 grams into this. The total weight will be the B. So, in this weight of this specific bottle and weight of the powder also there. This is B. Then after that, we'll fill the water bottle by pipette close to the bottle by stopper and weight. So with the help of the pipette also, after putting the powder, we can fill. Otherwise, with the help of the fluid, we can fill the water. Then we'll close it that one. We'll take the weight. That weight will be the P. Then the weight will be the C. That one. Now after that, we'll empty the bottle and clean and fill with the water and weight it. That will be the D. So here 4 parameters we are going to take. The initial one is A. That is the dried after drying. What is the weight of this bottle? And second one is with powder. Bottle is specific bottle with powder. That will be the P. And third will be the after filling the water. What is the weight? That will be the C. Then we'll empty all the things and wash the bottle, clean the bottle. Then we'll fill with water. Then that weight will be taken. That will be D. So here we take A, B, C, D values. When you substitute these values into this formula, we'll get true density. ST B minus A by D minus A minus C minus B. For example, we'll take some values of the iron powder, determination of. For the calculation purpose, we'll take one example to determine the true density. So weight of the bottle, suppose there is 36.912 gram. Then after putting this sample into this bottle, that weight will be the 41.912. Then will after introducing the water into this sample, will take the weight. That weight will be 91.53. So for getting the bottle weight plus water, that will be the 87.80 means after washing this material, we'll wash the bottle and again we'll put the water. That weight will take, that is the bottle weight and water only. That weight will be 87.805. When putting all these values, we'll get the fluid density of 3.922. From this, we can understood that this is the procedure, and after getting these values, we'll substitute into the formula. We'll get the true density of the material. So now we will see the experiment. The first step, we'll take the 2 grams of fair clay powder from this. We'll take the weight of this specific gravity bottle.
$19.828.
19.82. So weight of the dried bottle. We are taking the limestone in this experiment first. So weight of the dried bottle is 19.828. Then we will introduce the powder, limestone powder. We'll take 2 grams. Now we introduce this powder into that specific gravity bottle. Now we'll take the weight of so here no need to take the weight of that powder and bottle because we already measured that powder of 2 grams and we added. Now we are filling the water into that powder in which the limestone powder is there. Now after filling this water, now after introducing the water, so we'll take the weight of this bottle plus powder plus water. $46.42. The bottle is washed and we are filling with water. Now bottle is washed and it is filled with water. We'll take the weight of this bottle with water. 45.56 weight of bottle plus water. Now we'll repeat the experiment for fireproof powder also. First thing, as usual, we are taking the dried bottle, right?
Taking 0.812.
18 point. Now 2 grams of this fabric powder is added. Now the weight will be 18 plus 814 plus 2, 20.814.
This was $100.
Filling the water into that bottle which contains this fabric powder. Now we are taking the weight of this bottle plus powder plus water. This is C. 45.42. So now the bottle is washed and we pour the water. Now we are taking the weight of this bottle and water. Now the second part of experiment is determination of porosity. Determination porosity of two materials we are taking here. One is fabric powder, so fabric and limestone. This is limestone and this is fabric. So we are going to calculate the porosity of these two materials. These are two cubic pieces of 20 into 20 into 20 mm. Already we tried this one at 120 degree centigrade for 2 hours, and these are free from loose particles also. Initially, we will take the weight of these two pieces. That will be WA. The weight of the dried two piece, that is WA. And second one is the weight of this cube will be soaked in the suspended boiling water. Here you can see water is there. It is kept on the oven. So water will be boiled. In that boiled water, we suspend this cubic raw material piece inside and will boil it for at least half an hour in the suspended condition. In that case also we will take the weight. That weight will be WB. Again I am repeating. So we will take the weight of this cube when it is suspended in the boiling water, which is boiling for 30 minutes. In suspended condition only, we will take the weight. That weight will be WB. And third, after that, surface bottle we will wipe and will take the weight of this cubic piece in air. That weight will be WC. So three weights are there. Initially, the weight we have taken in the air, that is WA, and after that the cubic piece in suspended condition in boiling water will take the weight. That weight will be WB, and after that whatever the water is on the surface will wipe out and take the weight of this cubic piece. Then that in the air only will take the weight, so that weight will be WC. After getting the values of WA and WB and WC, we'll substitute, we'll get different parameters like solid volume we can calculate, apparent solid volume DAS we will calculate, apparent porosity we will calculate, apparent solid density SAS also we calculate, and finally we need the true porosity. For calculating the true porosity, it is the formula 1 minus SAS by ST into 100. This ST is nothing but true density, which we have already calculated in the previous experiment. That is true density. For example, we'll take some values and understand, we'll substitute those values into the formula. So how we'll get these parameters. The weight of the cube in air, WA equal to 35.1 kg. The weight of the piece that is soaked and suspended in boiling water, that is WB, will be 27. It is lesser than the initial weight we have taken in the air. This is WB. And finally, once the water is wiped from the surface of the specimen, we'll take that weight. But the weight of the test is soaked in water and suspended in the air. That will be 36.728. So we are getting WA, WB, WC, and when we substitute all these values in these formulas, we'll get the solid volume, apparent solid volume, apparent porosity, apparent solid density, and for calculating the true porosity, this SCS already we know apparent solid density, and true density we get from the previous experiment. So we got is 9.1%. As for understanding this calculation by using the observations, we can calculate like this. Now we are taking the weight of this cube in right condition, that is the air we are taking. So that is WA.
8.274.
8.274. Now we are suspending this cube inside the water. So we have to make sure that that is totally immersed. The water should be there on the above the surface of this cube. We can see the bubbles are coming out. Entering into that bubbles. But water is entering into the pores of the specimen. Now we are taking the weight of the cubic piece soaked with a suspended water in boiling water, because 30 minutes is already boiled. We are taking the weight of this P, WB.
5.295.
5.29. Okay. So after wiping this surface, we are taking the weight of the cubic piece after wiping, which is soaked in water and suspended in air. This is WC.
15.394.
Now we are taking the weight of this limestone. This is the weight of the cubic feet, which is dried at 110 degrees centigrade cut over. The weight of the dried cubic feet is WA. The WA is 18.123. And the water then. So the fabric which is suspended in the boiling water, now it is already half an hour it is boiled. Water is entered into that pores. Now we are taking this weight of the cubic feet, that is limestone, which is suspended in boiling water. That is WP.
11.669. देखा ना?
Now we are taking the cubic feet plate. After wiping the water on the surface, the weight of the cubic feet soaked in water and suspended in air, that will be WC. So WC of the limestone is now 18.4. 8.4. So, in the given experiment to study the apparent porosity, true porosity, and voidage of given raw materials iron ore, coke, limestone, fire bricks. So, in this segment, we are going to calculate the voidage of different raw materials. Mainly in the experiment, we are calculating the bulk density of the material, which is related to the voids. For doing the experiment, what are the equipment and materials are required? One is a pan balance, 5 kg. You can see the red one, and wooden cubic box. You can call it easy cuboid, 7.3 centimeter into 7 centimeter. The depth is 5.5 centimeter. So dimensions are 7.3, 7, and 5.5. So with the dimensions, we can calculate the internal volume of this box. And the raw materials which we are taking of size -6 plus 4, iron ore, hard coke, limestone, fire bricks. We know that the bulk density is the ratio of the mass of the material by bulk volume. Mass of the material means the mass of the many particles which we are putting into the known volume to bulk volume. Bulk volume involves the volume of the particle also, and there are voids in between the particles, that void volume also, and there may be some force on the particle also. So these three volumes includes the bulk volume. Bulk volume includes this particle volume. When you are putting more particles into this, their voids will be there in between the particles, that volume, and the particle may contain some pores, that volume also, that is called bulk volume. So this bulk density is depend upon the shape, size, and size distribution of these particles. If the particles are spherical, we'll get high bulk density. If particles are irregular, we'll get medium bulk density. If the particles are flat or angular, then we'll get low bulk density. If you are taking the combination of 70% larger particles and 30% smaller particles, there we'll get a lowest void volume, because this voids plays an important role in the aerodynamics of the blast furnace. This will affect the process parameters like temperature and iron ore reduction and the productivity of the blast furnace also. That's why this void study is very important. So voidage is related to the bulk density. If bulk density is more, then voidage will be the less. So after doing the experiment, then we can find out how the values are coming out. Now we are determining the bulk density of the first material, iron ore. We know that the box dimensions 7.3 into 7 into 5.5. The volume will come to 81.05 centimeter cube. So the bulk volume is BB equal to 281.05 centimeter cube. Now we'll take the weight of this empty box WF that is already taken. That will be 125 grams. Now we fill this box with the iron ore. So should not tap, we will fill the material. That weight we will take. That will be the W by. It is a simple calculation, bulk density. So now we are filling this box with the iron ore. So the weight of this, after putting the iron ore into the box, the weight will be the 750. 750 grams. So here I am writing 7. Then the mass of the material will be Wy minus Wx, means 750 minus 125, it will be 625. The bulk density equal to Wy minus Wx by Vb, it will come around 2.2. This way we will determine the bulk density of this iron ore. Bulk density of the, we know the dimensions. Now we are determining the bulk density of this coke. Already we know the box dimensions, box volume, weight of the empty box also we know, that is 125 gram, the same box. Now we are taking the weight of the coke which is filled in this box, that is coming 300. Now the mass of the material will be W minus Wx, it will coming 175 gram. And the bulk density will be 0.62. It's a simple experiment. Now we are calculating the bulk density of the limestone. The volume will be 281.05. The weight of the empty box will be the same like as previous, 125 gram. Now we are taking the weight of filled with limestone, weight of the limestone filled in that box, that is Wy. That will be 525 grams. Then the mass of material will be 400. And the bulk density will come around 1.42. Here we are determining the bulk density of this fire brick. So So we know the volume BB is 281.05. The weight of the empty box is 125 gram. So the weight of the box filled it with fabric WY is equal to 375 grams. And the mass of the material W minus Y minus WX equal to 250 grams. And the bulk density will be 0.88. Now, when we are comparing the bulk density of iron ore, coke, limestone, iron ore is having more density, bulk density, and this limestone is having 1.42 medium, and coke bulk density is 0.62. That is in between. The practicals. While doing the experiment, certain care should be taken, otherwise we will not get the right values. That's why in this discussion we have taken the values of average, means number of times experimented, the average values are taken, that we are going to discuss in this segment. Generally, if you are seeing the experiment, it is about bulk density and porosity. Porosity means pores. Pores will be different. Three types are there. Open pores means those pores are exposed, open to one side. It will be good for iron ore. If open pores are there for coke also, if open pores are there, then it will be will get a very good reduction of this coke also. Like that, if sealed pores are there, means pores are inside the material. Those will not be visible. That will be better for using that material as a insulating material. Some interconnected pores will be there from one side to other side. Those things, those materials are good for filters. So here we are seeing the densities of the material: true density, apparent density, bulk density of three materials: iron ore, coke, and limestone. All the densities, we can see the common one, the mass of material will be there, same, but the denominator, that volume, will be different. In case of true density, we are taking the volume without pores. In case of apparent density, we are taking the volume with sealed pores. In case of bulk density, we are taking the volume of three things. One is pore volume, other is particle volume, and third one is when you are putting the material, there will be a gap between the particles. Those are called void. That void volume also. So it is a combination of three volumes. One is particle volume, other one is pore volume, a third thing is voids volume. In iron ore, we can see the true density we got 3.67. The true density of HMTET is 4.9. So this 3.67 is nearer to this value. What indicates the true density of iron ore? Indicates the percentage of iron ore is more. So this true density of iron ore decreases with increasing the gangue content. In case of coke, the value of true density is 1.55. It will give the indication, the true density of the coke give the indication of the degree of graphitization. In case of limestone, the true density is 2.58. That is in between the iron ore and coke. Here in apparent density, when we are seeing, it indicates the percentage of pores. That is 3.2 in case of iron ore. So more porosity means the more will be the iron reduction. Here the apparent density is 0.89 in case of coke. So if In case of high porosity is there, what will happen? High gasification will be there. A high gasification means the strength after the gasification will be reduced. In case of limestone, that apparent density, that is 2.45. If you are seeing the values between the true density and apparent density, it is almost nearer. Means it will indicate the less pores. The material is dense. Bulk density of iron ore, it is showing 1.9 and coke 0.67 and limestone 0.90. This limestone bulk density is in between the iron ore and coke. Coke bulk density is more 1.9. So what it will, all these bulk density indicates, it will give the indication that how much storage space we have to provide that one. Here porosity we are seeing, the porosity of iron ore, we got the value of 12.8. This porosity is less when you are comparing with the pellets. Generally pellet porosity is 20 to 25%. 20 to 25%. So then what will be the iron ore lumps when we can use as a secondary choice if we need a fast reduction. Coke, if you are seeing the apparent porosity, the open porosity is 37.2, is very high, it's very good. That's why total porosity we are getting 42.5 for coke, means it is good for blast furnace and cupola. Limestone, apparent porosity is 4.49 and sealed porosity is 0.51. It is totally 5. Means the material porosity is very less if this is a dense material, limestone. In case of insulation fabric, we can see the open porosity is more, that is 35.1, and sealed porosity is 13.3. The total porosity will be 48.4. What it indicates means instead fabric is having more porosity, more pores. What will happen if we are using these bricks as a front lining? Then the metal and slag will enter into the brick, the bricks will fail. So we should not use.